Imagine the ground beneath your feet shaking as a series of explosions rip through the quarry, sending massive chunks of rock skyward. No, this isn't the set of an action movie, it's just another day at Namibia's Owarongo cement plant, one of Africa's most advanced cement production facilities. Cement manufacturing starts with a literal bang, blasting raw materials like limestone, clay, and silica straight from the earth to kick off a process that's as dramatic as it is essential. Precision blasting, turning rocks into raw materials. The magic begins with sheer precision. 30 holes are meticulously drilled into the quarry, each strategically placed to ensure maximum efficiency. Into these holes go powerful cartridges, followed by a generous filling of ammonium nitrate, yes, the same explosive used in mining operations. To make sure the whole thing goes off like a well-planned fireworks display, detonators are inserted into each hole. Then, the countdown begins. The site is cleared, and in a controlled detonation, the ground rumbles, sending rocks tumbling down in a steam worthy of slow-motion replay. A mountain of resources that lasts centuries. If you think cement plants are running out of raw materials anytime soon, think again. The quarry at this site in Namibia holds enough limestone, shale, and marl to keep production going for another 300 years. That means today's cement could very well be used to build the foundations of cities our great-great-grandchildren will call home. But to get from raw rock to a finished product, there's still a long way to go. Crushing giants. How raw materials get a makeover. Once the limestone, shale, and marl have been blasted free, they are loaded onto massive 60-ton trucks, basically monster trucks of the industrial world. These beasts haul the rocks to a crusher, a machine so powerful that it can process a whopping 600 tons of material per hour. The result? Rough gravel-like material, the first step toward turning rocks into a substance strong enough to hold up skyscrapers. The science of mixing, creating the perfect cement blend. Ever tried baking a cake and ended up with lumps of flour? Imagine making cement without blending the ingredients properly. Disaster. That's why after crushing, the materials are moved to a mixing bed where they are evenly combined. This careful blending ensures that every batch of cement has just the right balance of limestone, shale, marl, iron ore, and gypsum, creating a high-quality final product. Rolling over traditional methods. Why roller mills rule. Traditional ball mills are like the outdated, energy-hungry grandpas of cement production. Enter the modern-day roller mill, a machine so efficient that it cuts power consumption by 30% compared to its old-school counterparts. This means that while the process is still intense, it's at least a little friendlier to the environment and the electricity bill. The heat is on. The clinker transformation. Cement making is not for the faint of heart, especially when temperatures hit an unbelievable 1,450 degrees Celsius inside the rotary kiln. At these hellish temperatures, the raw mix undergoes a complete chemical transformation, morphing into clinker, the crucial intermediate product in cement production. But what fuels this inferno? An innovative, sustainable approach. Namibia's cement plant uses invader bush from surrounding areas as fuel. Talk about turning a nuisance into an asset. This high-temperature process ensures the formation of compounds like alite and bolite, which are responsible for cement's strength. The efficiency of heat transfer in the kiln determines clinker quality and energy consumption. Reducing CO2 emissions in this phase is a key focus for modern cement plants aiming for sustainability. Cooling things down, the final cement transformation. Once the clinker emerges from its fiery transformation, it has to cool down fast. The temperature drops rapidly to 100 degrees Celsius in a cooling unit to maintain structural integrity. From there, the clinker is finely ground with gypsum and sometimes limestone. Gypsum, the secret ingredient, ensures that when cement is mixed with water, it hardens at just the right pace, not too fast, not too slow. Cooling efficiency plays a critical role in clinker reactivity, influencing the final cement properties. The grinding process is optimized to achieve the perfect fineness, balancing strength and workability. Sustainable grinding techniques, including energy-efficient mills, help reduce environmental impact while maintaining high-quality cement. Billions of particles in every kilogram. Ever felt like you were inhaling cement dust at a construction site? That's because it's ridiculously fine. Just 1 kilogram of cement contains around 300 billion grains. That's more than the number of stars in our galaxy. Each of these particles plays a crucial role in forming the strong bonds needed for construction. After rigorous quality checks, because nobody wants weak cement holding up a building it's ready to be packed and shipped. The finer the cement, the better it binds with water and aggregates, ensuring long-lasting structures. Cement packaging, the final stretch. With demand soaring, efficiency is everything. The high-speed packaging system at this plant churns out an incredible 6,800 bags per hour, each weighing 50 kilograms. That's enough to stockpile cement for entire cities in record time. These automated systems ensure minimal wastage and precise filling, making operations seamless. To put it into perspective, 1 hour of packaging at this plant can fill enough bags to construct a 5-story building. Now that's productivity. With such advanced technology, construction projects can stay on schedule without worrying about material shortages. From cement to bricks, the backbone of construction. Construction is a symphony of materials working together, and while cement provides the bond, bricks offer the structure. These age-old building blocks have been used for centuries, evolving from sun-dried mud to high-tech, kiln-fired units. Their strength, durability, and adaptability make them an essential component in everything from small homes to towering skyscrapers. Beyond their structural role, bricks also contribute to insulation, helping regulate indoor temperatures efficiently. With modern advancements, eco-friendly bricks made from recycled materials are gaining popularity. As construction techniques evolve, bricks continue to be a timeless and reliable element of the building industry. The brick-making process: crushing, extruding, and baking. The journey of a brick begins with raw clay, which is sourced from natural deposits and stored to improve its consistency. It is then crushed and ground into fine particles, making it more pliable for shaping. After refinement, the clay is pushed through an extruder, shaping it into long, continuous slabs before being sliced into precise brick-sized units. These freshly cut bricks undergo a crucial drying phase, where excess moisture is removed to prevent cracks during firing. Once dried, they enter massive kilns, where intense heat solidifies their structure, making them weather-resistant. Finally, after cooling, the bricks are sorted, graded, and transported to construction sites, ready to form the foundation of new buildings. The heat treatment, from soft clay to solid brick. After shaping, the bricks take a trip to the firing kiln, where temperatures skyrocket to anywhere between 900 degrees Celsius and 1,100 degrees Celsius. This extreme heat solidifies them, transforming them from fragile lumps of clay into the durable bricks that will soon become homes, offices, and schools. The intense heat also ensures that any remaining moisture is removed, preventing cracks and weaknesses. This process enhances the brick's structural integrity, making it resistant to harsh weather conditions. Each brick emerges from the kiln stronger, ready to withstand the test of time. Cooling, stacking, and ready for use. Once out of the kiln, the bricks must cool before they're stacked onto pallets. Each pallet holds around 500 bricks, stacked carefully to prevent breakage. These bricks are then transported to construction sites, where they become part of the ever-growing infrastructure shaping Namibia and beyond. Workers meticulously inspect each batch to ensure consistent quality and strength. Proper stacking prevents damage during transportation, ensuring that every brick reaches its destination intact. From small homes to towering buildings, these bricks play a crucial role in shaping the future of construction. The future is built on cement and bricks. And there you have it, the thrilling, yes, thrilling, Journey of cement and brick production. From the thunderous blasts at the quarry to the extreme heat of the rotary kiln, every step in this process is a testament to human ingenuity and industrial strength. These materials are more than just building blocks. They're the foundation of cities, the backbone of infrastructure, and the unsung heroes of modern civilization. And that, my friends, is how rocks go from being useless lumps in the ground to holding up skyscrapers and bridges. If you enjoyed this wild ride through the world of cement and bricks, smash that like button like a quarry blast and subscribe before the cement dries. Got any thoughts, jokes, or random brick-related puns? Drop them in the comments. We promise not to cement over them.